Okay, so we're going to look at the ideal gas law in this video and another one coming up right after this. There were two different ways that we talked about working ideal gas law problems. One we said was a plug and chug type, where we just plug into the ideal gas law itself. We calculate for one of the variables. The other type was what we call an initial final problem, where we have two different sets of conditions. And so you might be saying to yourself, well, how is it that we would ever be able to figure out which problem which solution type, which way to work a problem goes with which problem? And it actually is fairly straightforward. See, our problem today talks about a gas cylinder. It has some volume of gas in it at some pressure, and it says, tells us what the temperature is, and it says how many moles of gas are in that gas cylinder. If you notice in this problem that we're working, it only gives us one pressure, one volume, one moles, and one temperature, one of each. If this were an initial final type problem, they would give us two pressures, or two volumes, or two temperatures. It would give us two of these different parameters. And that's sort of a key, a little tip that you can use to decide which solution type or which way to solve a problem is based on, do they give you more than one of the same thing? If they do, it's generally going to be the initial final type of problem. And so you see I've written the ideal gas law up here. This we've already talked about as being in one of these plug and chug type problems. And I've also put all the variables here. Now, it says we have a gas cylinder, has a volume of 29.5 liters. So it's sitting there, the gas is in this cylinder, compressed at a very high pressure, and it contains the helium at a pressure of 300 atmosphere. Now I'm going to tell you right away, when I see that as it's written, I look and I say, 300 atmosphere, one significant figure. And the reason why I note that is because everything I have going on in the ideal gas law is multiplication and division. So it's going to be counting the number of significant figures and then choosing the smallest number. So I know already this number is probably going to limit the number of significant figures at the end. One of those things you ought to keep your eye out for as you're working. It says if the temperature inside the cylinder is 298.15 Kelvin, how many moles of gas are in the cylinder? That's the one that we don't know. You might say, oh, Dr. Ramsey, they don't give you R. But remember, R is our constant. 0.0821 liter atmosphere mole Kelvin. So now we've got 1, 2, 3, 4 of the 5 values. It's just simply plug and chug at this point. Now, what do? Just start plugging everything in. We've got a pressure of 300 atmosphere. We've got a volume of 29.5 liter. We don't know the number of mole. We know 0.821 liter atmosphere mole Kelvin, and we know the temperature is 298.15 Kelvin. Already you should start to see things are going to be crossing out. Atmosphere will cross out, liter will cross out, Kelvin will cross out, leaving us with inverse mole, and we're going to have to divide to get N, so we're going to end up with mole as our unit. It's a great way to tell whether you're doing a problem correctly, and you've heard me say this before. Does it work out to the correct unit? And I'm going to keep that in there just so that you can see. So you multiply this together, you get 8,850 equals N times 24.478. Okay, now notice if I keep track of significant figures, I have 3 here, I have 5 here, I've got 3 here, and 1 here. And you might say, it's very strange that you have not finished the problem and already you're worrying about significant figures. And the reason why is I think about them the whole way through, so they don't have to go back and rework the problem. So 3 times 1, this number should have 1 significant figure. This number should have 3. So, I divide both sides by 24.478, and my number of moles comes out to be 361.55. But I'm dividing a number with 3 significant figures into a number with 1 significant figure, so this should only have 1. So how do I round? Well, I start to the left, I count the number of places over, and I count 1. So I'm going to round to that place right there. Look to the right, it's a 6, greater than a 5, so it's 400 mole. Does it make any sense? 400 mole. Should we have a lot of gas in a very small volume in a gas cylinder? Well, that is the exact definition of what we have talked about. Compressing a gas to put it into a cylinder is for. We can get a lot of gas into a very small area. And so indeed, we have a lot of gas, 400 moles of helium, crammed into this 29.5 liter gas cylinder, which is perfect. Then we can take and use that for months and months and months at a time while it's in the laboratory. So, plug and chug type ideal gas law problem. These gas law problems are the types of problems students generally tend to like. They understand generally how to plug things into equations and solve for them. And so usually students like these types of problems. Also not difficult to tell the 2 different types of ways to work them apart. There are some clues that stick out a lot, or stick out very much like a sore thumb. And so this is one of the types of problems that you will be asked to solve.